In today's lesson, we'll be looking at probability. Our objectives will be to introduce probability, followed by 6 applications: rolling a 4, drawing a 4, rolling an even number, guessing an ATM access code, tossing a coin, and drawing a king or spade. So let's begin by introducing probability. The probability of an event is equal to the number of outcomes that make the event true divided by the total number of outcomes. Let me say that in English. The probability of an event is equal to the number of outcomes that make it true divided by the total number of outcomes. So let's look at how this works in a problem. What we want to look at now is the probability of rolling a 4 on a fair die. I do want to make sure that you understand die is the singular of dice. So I've got one die in my hand and I'm rolling it. Our probability will be the number of outcomes that make it true divided by the total number of outcomes. Well, let's start with the total number of outcomes. When I roll a die, how many possible things can happen? Well, I could get a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 things that can happen. How many of them would be a 4? Well, only one of them. So there's one outcome that would make it true. There are 6 of these, and there are 1 of these. So the probability is N of E, how many of them are there here, divided by how many of them are there here. And it's 1 divided by 6. Let's look at another problem. This time, we'll be asking what is the probability of drawing a 4 from a fair deck of 52 cards. Once again, the probability is the number of outcomes that make it true divided by the total number of outcomes. Let's talk about the total number of outcomes first. If I'm going to draw a card from a fair deck of 52 cards, how many possibilities are there for what I could draw? Well, there are 52 of them. The question then is, how many of those would make it true? Well, how many of those are 4s? Remember that in our fair deck of cards, there are 2 black 4s and 2 red 4s. So there's a total of 4 of these as well. So N of E divided by N of S is equal to 4 divided by 52. 4 cards would make it true out of 52 possibilities for what you can draw. If you reduce that fraction, you get 1 over 13. Let's look now at application 3, which is rolling an even number. What is the probability of rolling an even number on a fair die? Well, once again, our probability is the number of outcomes that make it true divided by the total number of outcomes. There are still 6 things I can roll, but the question this time is, how many of them are even? Well, that one is, that one is, and that one is. So there are 3 outcomes that would make it true. Probability is the number of outcomes that make it true divided by the total number of outcomes. So it's equal to 3 over 6. 3 of these, 6 of these. Reduce it to 1/2. Our next application will be guessing an ATM access code. What is the probability of guessing a 4-digit ATM access code? Now this should bring back memories because you already know how to calculate how many possible ATM access codes there are if they're 4 digits each. What you don't know is how to calculate the probability of guessing it. We still need the number of events that make it true divided by the total number of outcomes. And this is the one where we're going to need to go back to what you already know. How many possible ATM codes are there? Well, it's a digit. So how many things can go right here? 10. It doesn't say they can't be repeated, so how many things can go here? 10, 10, 10. And what do you do with those? You multiply those together, remember that fundamental counting principle, and you get 10,000. This is how many possible ATM access codes that exist. The question is, how many of them are right? If I'm trying to guess yours, how many do you have? Only 1. So your probability will be 1 out of 10,000. Let's toss a coin now. A fair coin is tossed 3 times. The following is the set of outcomes. You could get all 3 heads. You could get 2 heads and a tail. You could get a head, a tail, and then a head. You could get a tail, a head, and head. And you can read the rest of those. The question is, find the probability of getting exactly 1 head. Probability is still the number of outcomes that make it true divided by the total number of outcomes. Well, let me ask you, how many things make it true? Well, I have one head right there, one head in this list, and one head right here. So there are 3 things that make it true divided by the total number of outcomes. Well, it was 1, 2, 3, 4, 5, 6, 7, 8. So 3 divided by 8. And then our last application will be drawing a king or spade. What is the probability of drawing a king or spade from a fair deck of 52 cards? Now this one looks a little different, and there's a reason for that. This is a compound event. There's an OR right there. And when that happens, if they do not overlap at all, it's not an issue. But if they do, we'll have to do something extra. And here's what you have to do. If you want the probability of this event or this event, which is what we have right here, then you need to calculate the probability of the first one, right here, plus the probability of the second one, minus the probability of their intersection. Let's look at what this would mean. First of all, I want to know the probability of drawing a king. Well, there are 4 of them, so first one is going to be 4 out of 52. What's the probability of drawing a spade? Well, there are 13 of them, remember, so it would be 13 out of 52. And I'm not reducing those fractions yet, and there's a reason for that. Because now I also need to subtract, is there anything they have in common? Is there anything in this list that also appears down here? And the answer is yes, there is. There's one thing they have in common. And that's what I need to subtract. So it would be, what do they have in common? 1K, which is 1 out of 52. So it's the probability of the first event plus the probability of the second event minus the probability of the intersection. Another way to look at that is the probability of the first event, the probability of the second event, and take out anything they have in common because you've double counted it basically. When you do that, you'll get 16 over 52. Then when you reduce, you get 4 over 13. That's all I have for you today in probability. Have a great rest of the day, and I'll see you again soon. Bye-bye.